This video is going to demonstrate how we do regression and correlation using Excel. I've got a very basic example for us to have a look at where I've clearly defined like two sets of data. One set is going to be the temperature outside in degrees Celsius, and the next set is going to be, say, something silly like the number of gloves that are sold on a monthly basis. I've chosen this strange example just because it should be clear to see that temperature is the one that should be influencing the glove sales. It would be very hard to make a case to say that glove sales were influencing the temperature outside. So that's been able to us to define very quickly which set of data would be independent, so that would be the temperature, and we always label that as X, and which set of data would be dependent, so the glove sales, which we always label as Y. So the first thing that we normally do when we're tackling regression and correlation is we have a look to see what the data would look like on a graph. So we're going to create a scatter diagram, or on Excel they get referred to as, can also get referred to as XY graphs as well. So I'm just going to start by highlighting the two sets of data together because they're in columns next to each other, so we can just do them in one block. And then at the menu at the top I'm going to insert scatter diagram graph, choose the one which has points showing, and it'll give you a basic graph to start off with. Now what I'm going to do is I'm going to make it a bit more meaningful by adding titles and labels and things. So I've just clicked on the appropriate chart layout. I'm going to move it to one side, and then if you bear with me I will actually put in some titles. So what we'll say is this is showing, this is a scatter diagram for glove sales and temperature. Okay, so what we have along the bottom, that is our independent variable, and that would be the temperature in Celsius. Okay, it's trying to be clever and pick up what we've already labelled, and then on the side that is showing us the glove sales. And the last thing I do is just get rid of the legend there that says series 1, because I've only got one set, so we don't really need it. So the first phase would always be to draw this diagram and make some comment about what you see on the diagram. So here you can see that it looks as if that the data is quite closely grouped together, so you would imagine it should have quite a high correlation coefficient. As the temperature is increasing, then the glove sales are also going down. That would give you an idea that when you do work out the correlation coefficient it should be negative. And then also, because the data is quite closely grouped together, we should be able to try and put a straight line through it, i.e. a linear regression line. So we'll start off with the next stage, which would be to actually calculate the correlation coefficient. Okay, so if I just give it an appropriate label, and what I'm going to do in here is I'm just going to actually work out what that is. For regression and correlation, they're quite simple. It's just some functions that you would use. So for correlation, the function that you use is called equals correl. So just type in equals correl, open a bracket, and you can see that it asks you for two arrays of data. So that's just two different sets of data. You don't have to do it in any order, but it's a good habit to say that what you would do is highlight your values of y first. So I've highlighted those. I'll put a comma in to say that I've finished telling it that set, and then highlight the x values and finish off with a bracket. And you can see here that it's given us a very high correlation coefficient of minus 0.6. Minus is what we expected because the data is going down. So because we've got a very good correlation coefficient, we could attempt to fit a linear regression line to this. And for this we actually need two values. The two values that we look for are known as the intercept and the slope. So the intercept would tell us that if we actually had 0 degrees Celsius on a particular day, what the glove sales we would predict would be. So on our diagram we can almost guess that it should be around 12,000 just by looking at the way that the data is laid out on the diagram. The slope is a bit more complicated to see because it would say that if for every degree that the temperature went up, how would that affect the glove sales? The one thing we can predict in advance is that would be a minus number because the glove sales appear to be going down. So let's have a look and see what values we get. And what we need again is two functions, very easy functions, because for the intercept it literally is the word intercept that we use. So you go equals intercept, open the bracket. With the correlation, I talked about how it was a good habit to highlight your y's first followed by your x's, and that's because when using intercept and slope you do need them in that order, otherwise you are given the wrong values. And that will give you a prompt there to say that it's looking for known y's and known x's. So in exactly the same way as we did with the correlation one, I'm just going to highlight the glove sales because they're my y values, put a comma in, highlight the temperatures, close the bracket, press return, and it gives me my answer. And I said before that the graph would predict it to be around 12,000. Well, not bad, 12,506. I mean, you can't always predict that, but I just thought I chose this example because you can see how it relates to the graph above. For the slope, again, very, very easy. So again, it's the same word as before, so we just say equals slope, and again do known y's and known x's. So all I have to do is highlight glove sales again, put a comma in, highlight the temperatures that we've got, finish off the bracket, and that will give us our value. Again, the graph helped me realise that I would expect to see a minus value. In this case, it's saying that for every degree Celsius the temperature goes up by, we would expect the glove sales to go around by approximately 359 if we was to round it to the nearest value. And that is essentially all you need for doing regression and correlation on Excel.